Good evening, everyone. Welcome to the Aquarium of the Pacific. I'm Jerry Schubel, president of the Aquarium. It's great to have all of you here for the spring edition of our Aquatic Academy. Some of you will remember that last fall the theme was longevity, that we're living longer, healthier, and that we have to figure out how we're going to use that extra time in our lives and how we're going to pay for it. And the guy who put that program together, Russ Hill, is with us this evening. And tonight and for the next 4 Wednesday nights, we're going to be exploring the topic, so the Earth has a fever. The Earth isn't doing so well, and the health of the Earth affects our human health. So how do you reconcile this with the fact that we're living longer, healthier lives? And when we get through this, then I'm going to work with Russ Hill, and we're going to have a summit. And we're going to see how can we connect these two strands, that we're living longer and healthier, but the Earth's not doing so well. What can we do to change that? So you have the bios of our speakers, and to save time, we're not going to issue those. And you can read on one Anthony Barnosky over here, Jonathan Patz over there, and Patz. Don't call him Patz, he gets mad. Now, their position on the screen does not reflect their political persuasion, so don't. But we're very fortunate to have them here. If you would turn off your cell phones or put them on vibrate, we would appreciate it. And our first speaker tonight is going to be Dr. Anthony Barnosky, and I will just say that Tony's been here many times. He helped design this new wing and the content that is in it. And tonight he's going to talk about the Anthropocene. He is the director of the Jasper Ridge Biological Preserve at Stanford University, professor there, and he's professor emeritus from UC Berkeley. He's the author of many important papers and many important books. Please join me in welcoming Tony Anthony Barnosky.
Well, good evening. It's great to be here, and thanks, Jerry, for inviting me. You know, it's a topic that's pretty near and dear to my heart. I've been talking about these things actually for a couple of decades now, and eventually we'll get some slides up on the screen. But my task, I think, is really to give a sense of what the relationships are between the health of our planet and the health of us as people. There's actually a very intimate relationship that we haven't had to worry about too much for most of our history. And the reason we haven't had to worry about it is because up until about 70 years ago, the Earth was a very big place in relation to the numbers of people on the planet. Not so anymore, and that's what we mean when we say that we live in the Anthropocene. Anthropocene, what the heck is that? Well, you can explain it very simply. So if you think through most of our time on this planet, we were embedded in nature. Nature was all around us. We were kind of minor players. The situation's reversed now. Now nature is embedded in humanity. And that's what we mean by the Anthropocene. We live in the age of humans, okay? So much so that we can now define a whole new geological period. You know, for those of you who are high school students out here, and probably many others as well, you may well have had to memorize all these different scenes, right? The Paleocene, the Miocene, and so on. And each of those is characterized by something so unique on the planet that it leaves a record in the rocks that makes the rocks of that time period different from the rocks of any other time period. The signature today is all being, well, not all, but a good part of it is being put there by us, by people, okay? Scientists now are saying that the Anthropocene actually started around 1950. I won't go into that debate, but it's a fairly new time on the planet. And it's really the time that we've changed how the planet operates. We've changed the planet's operating system by influencing all the things that used to just go on without us. So we've changed the kinds of rocks and soils that are being deposited. We've changed the chemistry of the oceans, how lakes, rivers flow, how often it rains and snows. We've melted a good part of the ice, the cryosphere. We've changed the chemistry of the atmosphere. And we've even invented this new sphere, the technosphere, which feeds back on everything else in the Earth system, and which we depend on, and to an extent the Earth system depends on now too. So that's worked out pretty well for us up to now. You know, I just looked up a few statistics for this talk, and here's the kinds of things that we've done for ourselves over, well, more than the past 50 years. So I just compiled these statistics for 1990 to 2014, 2015. But world hunger, down 42%. That's great. Infant and child mortality, down 57%. And this is just since 1990, okay? People are living longer, about 10% added to our lifespan. Wealth is going up. GDP is 44% greater than it was in 1990. So pretty spectacular thing, this Anthropocene, for people, except if you look at what's been going on recently, okay? Now, world hunger, it was dropping. But now, starting in 2015, we went on the increase again. So now more and more people are going hungry each year. And at the other end of the scale, we've got, 2.5 billion people that are overweight in the world. So that speaks to some pretty dramatic inequality, right? And that's something I'm going to return to towards the end of the talk. But something to keep in mind with this next series of statistics I'm just going to throw up here on the screen. So again, infant and child mortality, very dramatic drops since 1990 till you get to around 2015. And then the drop is not so dramatic anymore. That's beginning to level out. And what children are dying from are the same old things, okay? Most of it, again, speaking to the inequality in the world, is in the developing world. You know, disease, diarrhea, pneumonia, malaria. So some of these are on the rise. Even in places where things are really good, i.e. the USA, we're actually seeing lifespan dropping. As of 2015, it began to go down rather than up. The causes are up there on the screen: drug overdose, suicide, alcohol, socioeconomic inequality. So things are going a little haywire over the last few years. And then the whole business about wealth. Yeah, GDP has increased dramatically since 1990, but if you look at it in a little bit different way, you see something that's actually a little cause for concern. So this thick blue line is the growth rate for global GDP, gross domestic product, and the red line is the rate of population growth. And if you look at the distance between this blue line and the red line, what you notice is that in recent years, that distance is closing down, which means that per capita, people aren't richer, they're getting a little less rich. Again, we're looking at huge inequality because that GDP that's going up is actually in the hands of just a few people rather than the many. So, these are different ways to look at human health and assess human health. Now let's think about the way that planetary health connects with human health and how they feed back on each other. So we've done a lot of things to the planet. And this is kind of an amazing photo that you're looking at. You can see the lights of our cities at night. You can see all of this airline travel and shipping travel that connects us. I think visually this tells you we have done a lot to our planet, and we've used our planet to help us. But now it's time to start thinking about, okay, how do we assess planetary health? And if we start connecting the dots between planetary health and human health, what do we see? So lots of different ways to think about planetary health, but this is a way that is pretty straightforward. It's something called the planetary boundaries diagram that was done by the Stockholm Resilience Center, led by Johan Rockström there. And basically, all you're looking at is assessments of various things you can measure about the planet, things like climate change, ocean acidification, and so on. And the green shows you the safe zone, and then yellow is, caution, and red is, oh man, we might be in trouble. And what you can look at is, as you go around the diagram, is that there are some causes for concern, okay? Now, the main thing I want to use this diagram for is just to highlight a few things that I'm going to make the connection with human health, and that is climate change, land system change, biogeochemical flows, and ocean acidification. I'll just say a few words about each of those as we go along. But it's super important also to recognize that these different pieces of the Earth system don't operate independently from one another, nor do they operate independently from us. So there's just all these feedbacks going on. So think of the Earth just like you think of a human body, of your body, right? Okay, your blood pressure goes up, that affects a lot of other aspects of your health. Okay, so let's think about land system change. How have we changed the land surface of the planet? Well, we've basically taken over more than 50% for our own use. Most of that for farming, but also, cities, highways, dams, and so on. So, what does that mean? How does that connect up to health? Well, in some ways, it connects up very favorable to health because we can produce a lot more food now, which makes a lot of people much more healthy, supports the larger population, and so on. It also makes less space for other species. This is what it looks like on the ground, okay? This is palm oil plantation cutting into a rainforest. So we've taken away 50% of the land surface that other species used to use. We're using it for ourselves. And one of the things that does is brings us into contact with that forest and disturbed border. So people are actually coming in contact with wildlife in ways that they have traditionally, but now they're doing it much more. And a great example of that is the bushmeat trade. This happens to be in Africa. Here you've got pigs, wild antelope, and monkeys, all being sold in the same market. Actually, a big source of protein for the people that live in these areas. But what that does is it brings us into contact with wildlife that have their own diseases. Those diseases can actually jump ship onto us. And here's how it works. So typically there'll be cycles of disease outbreaks in a given species, non-human species, totally natural. The host species has immunity to some extent to whatever pathogen it is, and everything works fine until two things happen. One, as we come into contact with those species more and more, and that can be direct contact, like the bushmeat market that I just showed you, or it can be indirect contact, for example, picking up ticks or fleas, whatever. And those pathogens have the potential then of mutating so that they can affect either our domestic livestock or actually us. And then we get a whole new disease into the human system. And that's called spillover. And that's exactly what we've been reading about in the news, okay? So the coronavirus outbreak that I just read about 2 hours ago that California has now just declared a state of emergency because of it. That traces right back to one of these wildlife markets in Wuhan, China. Notice the sorts of things for sale there. This guy, which is a wild animal, this is a price list, actually. Foxes, ostrich, rabbits, echidnas, and so on. And the real issue here is you get all of these species, oftentimes live in cages, crammed together in tight quarters. And it's just a perfect breeding ground for these pathogens to mutate and jump ship from one species to the other, which is exactly what happened in this case, okay? So ironically, one of the main animals that is being looked at as the source is a pangolin, and the jury is still out whether it's pangolins or bats or something else. But the reason I say that's ironic is because pangolins are one of the most endangered species on the planet right now. So here we have an illegal endangered species potentially transferring a new pathogen to the human species. So I don't know, maybe that's poetic justice. In any case, though, once you have an outbreak, you're reading about it in the news. Here's the statistics actually as of this afternoon. And outside, in China, things have begun to level off. So we're maybe in China moving past the worst of it. Outside of China, though, the rest of the world, you can see what that graph is doing, and that goes through day before yesterday. It's still going up. So very direct relationship between how we're transforming the land on the planet and new sources of disease. Now, it's not just the coronavirus that's an issue. It's actually not an unusual thing at all to see these spillovers. The one that got a lot of press a few years ago and still does occasionally is Ebola, which has a very high death rate that's been mostly confined to Africa. But all of these other diseases listed here are also spillover diseases. So, you've probably all had the flu at one point. That's essentially a spillover. Salmonella, West Nile virus, plague, SARS, rabies, brucellosis, Lyme disease. And as I was putting together this list, I realized that a lot of times we think, oh, well, those are just words. However, I've actually had, I work in kind of weird places and come in contact with a lot of animals. So yeah, I've had the flu. I've also had something like the plague. Seriously, I almost died from it. They never did figure out what it was. I've had brucellosis, and I've had Lyme disease. So, this is, to me anyway, it's a reality. And these are super important interrelationships between the non-human and the human system. Okay, so let's talk a little bit about biogeochemical flows. What are those? That's something else we've totally changed on the planet. So by biogeochemical flows, we mean the way various compounds and elements circulate through the natural system. And nitrogen is a great example, all right? Plants, nitrogen occurs naturally. Plants need nitrogen to grow, but actually under natural circumstances, there isn't much nitrogen, so that limits plant growth. In the early part of last century, we had the inventors of the Haber-Bosch process, which basically produced reactive nitrogen. So now we have orders of magnitude more reactive nitrogen in the system, same with phosphate. So we've really changed that biogeochemical flow. And the way we've changed it is we go out to our farm fields, as in this picture, broadcast this nitrogen and phosphate to increase crop growth. But not all of it gets used by the plants. A lot of it goes into the soil, it rains, percolates into the water table, into rivers, streams, and so on, and ends up in the oceans. Gets to the ocean, and it really increases the nutrient load in the oceans, where those rivers hit the sea. And that causes terrific algal blooms, which then die. And as they die, they suck all the oxygen out of the water. So nothing else can live there. So these dead zones are enormous. The red dots on this map are the actual dead zones, the red and yellow. And we actually we know how to fix these in some cases. So the green dots are recovering dead zones. But this has a tremendous effect on human health through fisheries. Very much declines the number of fish that are taken from the sea. Also, economics, obviously. So, again, these things that we do on land end up in the oceans and cause problems for us. Now, climate change, we've all heard a lot about climate change in recent years, I'm sure. We know what causes it: burning fossil fuels, increasing greenhouse gases. And you can see the graphs there of how much we've increased. It's not just what we put in the air. Much of what we put in the air is carbon dioxide, which reacts with ocean water, essentially turning it more acidic. And it turns out that the life of the sea is adapted to current ocean acid levels, and as we increase acid levels or make the ocean more acidic, We're seeing dissolution of shells of mollusks, oysters, and so on. We're seeing death of coral reefs. And this is already happening. It has the potential to turn into a great big deal, knocking out about 25% of all ocean life, essentially, which, again, food shortages would be a huge result. So a lot of times when I talk about climate change, one of the questions I get is, well, yeah, climate is changing, but isn't that natural? Climate has always been changing on the planet. And that's true. Climate does change. It varies, but it doesn't vary very much compared to where it's going nowadays. So this is basically just showing you how much Earth's average temperature has varied over 5 million years, okay? And there's different panels on here showing different scales of time. So this is over 1 to 5 million years, and all these wiggles, just read those as a temperature graph, all right? This is the average temperature for 5 million years, so sort of the normal set point. That's the Earth's 98.6, like your body is 98.6, except the Earth has a different set point. And then this panel is the ice ages going through hundreds of thousands of years. So this is a warm time during the last ice ages. This is a cold time. And then this period of stability here over the past 10,000 years and coming into the past 1,000 years is when civilization evolved. This is normal for us as humans, okay? And you can see not very much temperature variation at all compared to the longer term. And then we go into the last 100 years to the present, and we're about here now, and we're on track to do this. So if we stay on that track, when we get to this point in, about 80 years from now, Earth will be hotter than it's been in 14 million years. So there's actually no species on Earth, including humans, that has evolved to withstand either that amount of temperature change or that fast a temperature change. Not to say everything's going to go extinct, just to say that's where we get the problems, that very rapid rate and going to this place that living things really haven't seen before. Okay, so Jonathan's going to tell you some details about how that affects human health. And here's a list from one of his papers, I think. But you can read the list: air pollution, heat, severe weather, environmental degradation, water quality, impacting our food and water, and so on. But I actually want to focus you on something a little bit different than those direct effects, and something that the US military calls a threat multiplier, okay? Now, this is a super interesting graphic, in my opinion. This is from a talk by Vice Admiral Lee Gunn. And Lee is part of this organization called the CNA. CNA doesn't stand for anything, but it is a think tank. And part of this think tank is a military advisory board that advises our government and the military on issues of grave national security. And a few of the names are listed up there, and what you can begin to get a sense of if you read through those names is that these are the generals, the leader, the head of the Air Force, head of the Army, head of the Navy, head of the Marines. These are the big guys who have led troops at the top, okay? And upon retirement, they're in this think tank thinking about, all right, what are the biggest threats to national security? Climate change. 2007, climate change is what they came up with. And that's from one of Lee's talks at about this time, from the publication shown there. And poses a serious threat to America's national security. They coined this term threat multiplier. And here's how it works. And national security, wars, that's definitely a threat to human health, okay? Think about the global migration crisis. Several things actually have to come together to make people want to leave their homeland, okay? If you look at the countries that migrants have been coming from, it sort of reads like a who's who of war-torn, politically unstable lands, but all of them have these things in common. Rapid population growth, usually 2 to 3 times the world average. Some history of political instability, some history of ethnic rivalries within the country, lots of economic inequality. But yet, through all that, they hold together and people don't leave until you get something that causes a disruption in the status quo. And what is that something? What has it been in recent years? Climate change, okay? So here's a farm field in Syria after one of the most severe droughts, 2011-ish, give or take. People had nothing to eat. They didn't have water to drink. They left. Same sequence of events has been happening over and over again in all of the countries listed here. Sudan, Somalia, Egypt, India, Pakistan, China, Venezuela, Central America, Mexico, and the list goes on. So people are actually leaving because they're out of resources. The reason they're out of resources is because of extreme weather events on the increase. And where are they going? Well, they're going where conditions are better, where climate is more stable. And it's interesting to think of humans as any other species, okay? Just like any other species. What's happening is species are dispersing from the equator towards the poles. That's exactly what's happening. And clearly, that's a whole part of the human health issue as well. Okay, so that leads us into another thing that we have to think about when we're thinking about the relationship between planetary health and human health. And that is the whole planet operates, and our influence on the planet operates as a complex system, okay? And complex systems are exactly what the words say. They're very complex. There's a lot of interacting parts, and you mess with one part, and something happens to a different part. And in our case, in the planet's case, you know, the parts are, all right, how many people are there on the planet? How much stuff are we using? How's the climate feeding back on that? Likewise, how does that all come together to food, water, biodiversity, pollution, disease vectors, all these things? The thing to remember is you change any one of those and the other parts get tweaked as well. So for, I'd say for the state of the Anthropocene today, there's a couple of big drivers that we need to keep in mind. So one is how many of us there are, all right? And people talk a lot about, okay, how many people scientists talk a lot about how many people can our planet actually support? And that's a complex answer. But there's one thing we know, and that's there's probably going to be around 10 billion of us at least by the year 2050, in just 30 years, okay? These are projections based on various demographic models. The red line is if birth rates, fertility rates stayed exactly what they are, or what they have been over the past decade or so. And that line goes way up, over 20 billion. Nobody really believes that A, the Earth could sustain that, or B, that we'd really get there, because luckily fertility rates do seem to be coming down. More likely are that high, medium, and low scenario. Doesn't matter which of those you go for, though. The reality is by 2050, we're going to be right in here around 10 billion people, all right? So that's one part of the equation. And what's going to matter a lot is how much stuff we use, what we extract from the Earth, whether we get into things like a circular economy. It's pretty clear to see that there's a lot of inequality in the world. I told you I'd come back to that. That's no surprise to anyone, I think. But, if you just, again, I just pulled off a few countries here. US is way up here at the top, very, very wealthy. This is gross domestic product per capita. And look, we're at, 10 times, what's average for us is 10 times what's average for somebody who lives in most parts of Africa. So what we're looking at is us, the richest 1 billion people, are actually producing most of the detrimental effects on the planet. The poorest 3 billion, most of the world, if you break it out into economic sectors, is only producing about 5% of the problem. So for me, that leads to a pretty obvious solution, that the folks who are causing most of the problem also have the resources to fix the problem. And, if we just think about climate change, fixing climate change, what would that actually cost? What would it take? Well, one thing we know is we know that we can do it. We have the technology. And, during the Q&A, I can go into that a little bit more. But here's one calculation on the cost. It would take about $750 billion to $1 trillion per year for about 50 years. Oh my God, that's a lot of money. However, the richest 1 billion, divide that up. Think you could afford $750 to $1,000 a year? It's doable, is the point. So we tend to focus on problems a lot, but oftentimes the solutions are much easier than we like to make them. What holds us back is often the will. We're used to doing things in a certain way. We don't like to see change. But that's not to say that we couldn't do it if we wanted to. Will we? Don't know. Hope so. Okay, well, that's what I got for you. And I'm happy to take some questions and discuss.
If you raise your hand, someone will bring you a microphone, and that you can pose your question. We have time. While they're finding somebody, the only one that I found curious in your planetary boundaries is freshwater use that was well within in the green zone.
Yeah, so the whole planetary boundaries concept, there's a lot of slop in it, okay? And it depends on who you talk to. And you might have also noticed that there's nothing for human population size on the planetary boundaries chart. But speaking to the freshwater use, yeah, freshwater use is an issue. You know, I've forgotten the statistic off the top of my head, but I think it's somewhere in the neighborhood of a billion people do not have ready access to fresh water. So we're already not doing a great job on that, and if we add 2.5 billion, we have to feed, you know, another 2.5 billion people, which means we have to grow food. Right now in California, agriculture takes about 70% of our water. So yes, fresh water is a huge problem.
And with climate change, will get worse. So who has a question? Somebody, raise your hand and we'll get a microphone to you. You wait right over here. Adina, to your left.
Okay. Okay. So for us littler people, I'm 14, so I couldn't even drive myself here. I had to have my mom do it. So for us, we are probably not in the richest 1 billion people in the world, but what are some things that we could do in our everyday lives to help sustain the Earth's health?
So, you know, I think the best thing that somebody at your stage can do is to really learn about these issues. And as you are, you know, thinking about a career or thinking about what you're going to do for a living, direct your energies towards solving them. You know, and there's a lot of different directions that we need to come at from solving them. You know, if you want to be a lawyer, man, do we need the legal teeth on this? If you want to be a teacher, communicating the issues. If you want to be a doctor, putting together how health of people connects with health of the planet. So really any profession that a person is involved with, there's a way to get involved in these problems.
And learn how to collaborate, because as was pointed out, these are very complex problems. They don't fall within any single discipline, so learn how to collaborate with people from other disciplines. Who has a hand up? Up in the back, okay.
I want to thank you for all the information that you shared with us. It's quite amazing, and it's always good to be informed. Now, regarding the COVID-19 outbreak that's taking place, when we listen to the news and see the news, they're not really, from what I've seen, linking it to like the Wuhan wildlife market and also to the pangolins, perhaps. So when I'm looking at how these species can affect people, particularly in very, very poor areas, and the amount of money that's now being used to treat people to try to find whatever medications that are needed, and now a vaccine. Looking at where this is taking place, wouldn't it be more feasible for mankind to try to find a way to get more healthy food to people so that this does not happen in the future? Is there any talk about how to prevent this instead of this is, when I looked at all the diseases have occurred, and then when you mentioned to me what you yourself had acquired, I was wondering what can we do and what can be done? Because as the population increases, the demand of food is going to decrease, and this could end up being even a bigger problem than what we're seeing today or even in the near future.
Yeah, well, so boy, would you run for political office? No, I think what we again, I think awareness is a huge, huge thing that we can do. Once people understand this, I think solutions are, can be formulated. And as far as where we spend our money, yes, I think it probably would make more sense to spend our money at the source preventing these things rather than after the horse is out of the barn.
And I think we heard over here, get educated, and Francis, I think your lesson is get involved. When Francis goes to the city council every Tuesday, if they see her coming, they try to lock the doors. But we thank you, Francis, for everything that you do. Another question? Okay.
So, Doctor, thank you. Excellent tonight. I'm 75 years old, and I need to do a lot of things before I leave this planet for my grandchildren. So you got me motivated that way. But secondly, you said we're moving away from the hot area, the warm areas, so we're going toward the cold, toward the place where we don't have ice anymore. Well,
right.
Interesting. So we're moving. Huh? Yeah.
Yeah, I mean, if you look at the general direction of movement, that's exactly what's happening. And, my background is to a large extent in biology and just thinking about how non-human species act. And we're doing the same thing. I mean, we're an animal species just like everybody else, and we respond to the natural laws. So as far as migration goes, it's just like you get too many squirrels in a tree, and some of them have to go to another tree. There's just not enough resources, and they're going to go to the tree that has the best resources because that's their best chance.
And fish in the ocean are either moving to greater depths where it's cooler water, or they're moving to higher latitudes. And those animals in the ocean, like coral reefs that can't move, they either adapt or they die. And it's not a very good prognosis. Anybody who's got?
Because of Earth's current health and of the environment, do you think the virus will improve or get worse within the next couple of months?
My only information on that is what the medical community and the CDC says, and everything I'm hearing from that direction is, yeah, it's going to get worse before it gets better, because we're still, you saw the graph that I showed, we're still on the really steep upswing, so there's going to be more cases before it tails off. Jonathan may have better insights than I do on that.
Jonathan should have the answer to that. He's got an MD and a Master's of Public Health, so we'll come back to that one. Who else?
I wanted to comment to the young person with the question about what can we do. It seems to me that we all have to figure out how to consume less, to eat lower on the food chain, to reuse our clothes, on and on and on, because this consumption is just out of bounds.
Yeah, I would agree with that. I mean, the trick for long-term global health is going to convert our thinking so that we use less. That doesn't mean we have to live a less comfortable life. It just means we use less. And on the other side of it, there's a huge proportion of the world that really could benefit from increasing what they have access to. So I think, the over-consumers coming down, the under-consumers coming up to a suitable level is where we need to be headed.
And related to that, throw less away. We throw less away.
Yes, exactly.
One more right here. Hi. I've totally enjoyed this. I was wondering, with the increase of solar, wind, and hydropower resources, and we're still extracting fossil fuel from the earth, is it more, has it helped any to use hydro, wind, and solar, or are we extracting the same amounts of fossil fuels, making things just as bad or worse? Do you know what I mean?
Yeah. So still most of our energy production does come from fossil fuels. However, over the past decade, we've seen a steady ramping up of renewables. And I think what it's going to take to really make that switch probably is going to be incentives at the higher levels to help the profits of the non-renewable industries get off the ground. And people hear that and they say, oh, well, that's a stupid idea. However, if we took the amount of subsidies we give to the fossil fuel companies and gave them to the renewables, that's all we have to do.
This is your one opportunity to ask your dad an embarrassing question. Do you want to ask him a question? No? You're okay? All right. I would just close by, I think there's something for every one of us to do. The 75-year-old gentleman up there, I'm older than you are, and I think we talk about we have to educate the young, and we do, but the decisions that will be made over the next decade are going to determine the future that many of our young people will live in. So we better get with it. Anthony, thank you very much for a great talk. All right, we're going to move right into our second talk, I think. And so you're going to hear from Jonathan Patz, MD and MPH. He's a professor and director of the Global Health Institute at the University of Wisconsin. He's also chair of the Department of the Environment and Human Health. And he's going to talk to us about treatment for today's climate emergency can actually save the lives of way more people than we ever imagined. And we have a number, 5 or 6 University of Wisconsin alumni here, right? All right, please join me in welcoming Jonathan Patz.
Thank you, Jerry. Yeah, we have to do a little bump there, right? Okay. Jerry, thank you. It's an honor to be here. I've never presented on such a big screen before, so this is really cool for me. And Tony set up this lecture. We've been working on coordinating this for the last 2 months now, and you'll notice that every 5 slides or so, he's teed this up perfectly for my presentation. So Tony, thank you very much. So you can see from the title that I'm going to talk about treatment for today's climate emergency can save way more lives than we've ever imagined. So I'm going to talk about climate change, climate crisis, and why it's a health emergency, and why solving the problem could be the greatest health opportunity of the century. So, as was alluded to before, look at life expectancy. It's never been a better time to be alive than right now. But as Tony has pointed out, the good news is coming at the cost that we only have realized recently, that we're over-consuming natural resources. And so we're living high on the hog today, but we're sacrificing future health, the health of future generations. And Tony talked about the planetary boundaries. And tonight, my job is to focus in on climate change, this particular challenge, this planetary boundary that we are exceeding, as you can look at the red, and talk to you about why it's such a big deal, why it's so important. And I want to show you some data from James Hansen, the famous NASA climate scientist. This is actually a graph of measured temperature. It's not modeled temperature. This is measured ground temperature in the northern hemisphere over time. And I'm going to march through the years real quickly, and I want you to focus on, notice there are very few red, extremely hot days, but as we move forward, watch what happens to that. So here we go. This is average summer temperatures from 1951 to 1980, 83 to 93, 94 to 2004, 2005 to 2015. It's absolutely getting hotter. And the situation is getting worse than the climate scientists predicted. And recently, the United Nations has been talking about signals around the world that are indicating things are really changing faster than expected. Of course, you know, last month, Australia was totally on fire. And so this is very concerning. So I served on the United Nations Intergovernmental Panel on Climate Change for about 15 years. This is one of the latest assessments. Tony put a graphic on here, and this just shows you that the world is heating up. These are the projections for best case scenario over here. If we go cold turkey on fossil fuels and this RCP, representative concentration pathway of emissions that leads to 2.6 watts per meter squared warming versus the higher one, the RCP 8.5, which would warm up the world on average 7 degrees centigrade, which is quite rapid and quite a lot. Notice that the poles are warming twice as fast. The North Pole is warming the most compared to the other places of the world. So you look at, this is warming, and from my point of view, you know, I'm a health scientist, and when I look at the physical attributes of climate change, rising temperatures, sea level rise, and hydrologic extremes of the water cycle, more droughts, floods, and fires, from my point of view, I'd say, okay, well, so what? So what if it's warming? And of course, the issue is that climate change can affect our lives through these multiple pathways. Each one of those pathways has multiple climate-sensitive diseases and health outcomes that are quite concerning. So heat waves, air pollution, stagnant air masses from heat waves and causing air pollution, as well as aeroallergens like pollen. Infectious diseases. Tony showed a slide about, you know, why insect-borne diseases could be quite problematic. I'll show you some case examples. And waterborne diseases, thinking about extremes of the water cycle, more flooding and more droughts. And of course, with droughts, we have problems with water supply, food supply, malnutrition. The bottom one, mental health and environmental refugees. Mental health from post-traumatic stress, and also concern about, there's also a new term called pre-traumatic stress, when you have repeated extreme climate disasters. The bottom one, environmental refugees, Tony talked about this and showed many countries where this is a problem. And I want to just go back and dive into the one country that he talked about, which is Syria. And if you can't read these graphs from the back, but I'll just tell you that the top graph is looking at rainfall that's falling. This is temperature increasing. This is a Palmer drought index and population increasing. You put those all together. Well, the Palmer drought index indicated that right before the Syrian civil war, they had the most severe drought in the instrumental record, according to this study in the Proceedings of the National Academy of Sciences. And as Tony talked about migration rates, they were documented that there was rural to urban migration from the droughts and the failed crops 4 times faster than normal. People were flooding into the cities in Syria. And of course, there were food price shocks, there were riots in the street. And so this environmental stress leading to really disruption of civilization in that country may have been the precursor to the war that killed hundreds of thousands of people and led to millions of refugees. It's these situations that are very difficult to prove, but with this association, this indirect effect of climate extremes in a location could be the biggest problem of them all. And frankly, I think this population dislocation and forced environmental refugees could in fact be the iceberg under the tip of the iceberg for problems from climate change. So let's focus on some things that we know more directly. Temperatures. We know that heat kills. This is an aerial image of Chicago during the 1995 heat wave that killed 700 people. Notice not only does a heat wave cause mortality from heat itself, but the stagnant air masses lead to terrible air pollution. And when we published this paper, the journal thought this was about air pollution. Our study was really about heat waves. They called this the Wheezy City because they thought it was an air pollution paper, but it was actually about heat waves. So this is a problem with heat waves, air pollution and heat, and of course this is from the latest assessment from the Lancet Countdown, which is looking at health and climate change and seeing in the United States the increased frequency and intensity of heat waves in the United States. We've done some modeling, asking the question about extreme temperatures, and this is for the city of Milwaukee. Right now, Milwaukee only has 9 days that are hotter than 90 degrees Fahrenheit. But in the future, by mid-century, 30 years from now, that number will almost triple. So Milwaukee will have 25 days hotter than 90 degrees Fahrenheit compared to 9 days. So that's very concerning for public health. And of course, in California, you have another problem with heat waves and droughts and the problem of forest fires. And there are more and more studies talking about the smoke effects on health. And so this is a problem that is being seen more in California already. What about the rest of the world? This is a map showing future summers. And everything, the top one is looking at mid-century. Let's focus on end of century. Everything in red has a 90% probability or greater of experiencing record-breaking summer temperatures. Now that's a problem when you think about food supplies. And if you have a climatic envelope through which crops grow, and so if it gets too cold, crops can't grow. If it gets too hot, they can't grow. According to Roz Naylor at Stanford University, with these record-breaking temperatures, you know, the number of people at risk of hunger today could double by mid-century. That is an enormous public health challenge. And of course, because we're in the aquarium, I had to talk a little bit about, you know, our nutrition from the ocean. And Tony got into this a little bit about the health of our coral reefs. Right now, it's estimated that 27% of reefs are considered to be dead, at least half attributed to sea surface temperatures, warming from climate change. And those of you in the audience know more about coral reef bleaching than I do, but I just put this up here as a reminder about, you know, these the symbiotic relationship with these zooanthellae, which I don't know how to pronounce, to be honest, related to temperatures, and that warming temperatures are causing coral reef bleaching, and it's quite serious. Well, just last fall, or a year and a half ago, the Intergovernmental Panel on Climate Change was asked to conduct a report after the Paris Agreement. And in that report, they came out with estimates of what 1.5 degrees centigrade warming would do to coral reefs. As far as calcium building coral reefs, they estimated that 1.5 degrees warming would kill 70 to 90% of coral reefs. If we get to 2 degrees warming, 99% loss of coral reefs. That was quite striking to me. That's pretty scary. And when you think about health, And what do coral reefs do? They support fisheries. This is according to the World Health Organization. 1 billion people rely on fisheries as their main protein source. And more than 4 billion people depend on fisheries for a significant amount of protein, according to the Food and Agricultural Organization, FAO. Tony mentioned ocean acidification. This is more recently understood to be a very serious threat for our oceans. A quarter of the CO2 that's released by humans ends up in the ocean. The ocean absorbs that CO2 and is leading to more acidity of the ocean. And of course, as Tony mentioned, that has devastating effects with any kind of shellfish and coral reefs. So this is something that is very concerning, especially if you're into fisheries and if you are here at the aquarium. You all know about ocean acidification, but most people in the world are just waking up to this as a very significant problem. Also in the ocean, as the sea surface temperatures warm, you get these dinoflagellates that are popping up all over the world. Warmer sea surface temperatures are also a problem here, leading to neurotoxins like ciguatera, fish poisoning, and other types of illnesses when you eat those contaminated seafoods. Okay, global warming's greatest threat may also be the smallest. How many of you are high school students? Raise your hands. Okay, here's a question for you, okay? What's the difference between us mammals and that insect, that mosquito on the screen, besides the fact that we don't fly? And Jerry has promised me that at least 80% of you do not suck blood. So one of you students, yes? We don't lay eggs. Correct. Another one. Yes? Say again? Whatever you said was correct, but I'm not sure I heard it well. Up there. We have a spine, and they're spineless. Correct. I want another one that's a little more relevant. Yeah. What? We're bigger? We're bigger? Yeah. Yeah, okay. One more. Something about temperature. Temperature? Yes, right, cold-blooded. We are warm-blooded. Insects are cold-blooded. That means that our body temperature is always about the same, give or take if you have coronavirus. But still, our body temperature is about the same. What's the body temperature of that mosquito? It's exactly the same as the air temperature that surrounds her. And if she's carrying malaria parasites, temperature, it will completely determine the speed of development of that malaria parasite in the mosquito, or West Nile virus, or whatever the mosquito is carrying. Temperature will determine the speed of development and transmission dynamics. Here's the mosquito that carries yellow fever, dengue fever, and Zika virus. This is Aedes aegypti mosquito. And so temperature has a lot to do with transmission dynamics. We looked at the air temperatures around South America right before the Zika epidemic. And that winter of 2015 into 2016 turns out to be the strongest El Nino in recent history, or at least tied with 1997, but lasting longer. And look at the temperatures. We reconstructed the temperatures comparing to a 60-year average and found that temperatures were more than 2 standard deviations higher than a 60-year average right before Zika erupted in that area. And if you look at the ability of that mosquito to transmit virus, it's called the vectorial capacity. the mosquito is the vector of disease. If you look over a period of time, notice that the ability of that mosquito to transmit virus was the highest level it had been in 60 years, right before Zika erupted in Brazil and Colombia and the rest of South America. I've been telling people that because dengue fever and Zika virus are in the same virus family, and they're carried by the same mosquito, Aedes aegypti, that they'll behave exactly the same. Well, a colleague of mine published this a year and a half ago, pointing out that Zika virus, actually, the thermal minimum for Zika is 5 degrees centigrade warmer than that of dengue fever. So it makes us wonder if that intensive heat of that El Nino had something to do with Zika virus taking off. Now, every one of these infectious diseases is complicated. There's international travel. We think that the virus came from Polynesia, either from some big canoe race or from the World Cup, that the virus got to Latin America. But we wonder, just like when West Nile virus hit the United States, that happened to be the hottest July ever recorded in New York City's history. And we wonder, for this disease system, if Zika virus, it got there from international travel, but did it erupt because of the extreme temperatures? One other thing about ocean temperatures, showed the El Nino. The other thing that we know about with sea surface temperatures is a relationship with typhoons and hurricanes. So for those high school students up there, yes or no, do you think there's a strong correlation between the blue line and the green line? It's obvious, very strong. Well, that blue line is the power dissipation index of hurricane winds. And it's just a matter of physics that warmer sea surface that temperature drives the strength of hurricane winds. So we are seeing more Category 4 and 5 hurricanes around the world because of warmer temperatures. The climate scientists cannot tell you if we'll see more hurricanes hitting landfall. That gets very complicated. But all this is saying is that when a hurricane forms, if the sea surface temperature is warming, it will have stronger winds. And lastly, I want to remind you that it's not global warming, it's not just temperatures, it's also extremes of the hydrologic cycle. More heavy precipitation and more extreme droughts. This is looking from the U.S. Global Change Research Program, looking at the type of rainfall that is expected. This is a global average. And the bottom line is that in the future, when it rains, it will rain very hard because hot air holds more moisture. So it's not that it will rain more or less. It will be that when it rains, it's really going to rain hard. Is that a problem? Well, have any of you ever heard of something called combined sewage overflow events, CSOs? In the United States right now, we have more than 1 trillion gallons of sewage-contaminated stormwater that overflows into lakes and streams every year. That would keep Niagara Falls running for 18 days. So our country, which is sort of a developed country, we can't handle heavy rainfall events. We get these overflow events. And so this is going to worsen. We did a study in Chicago and found that by mid-century, because of the increasing intensity of rainfall, that Chicago will see a doubling in the number of these combined sewage overflow events. So we're really concerned about the safety of our drinking water when you see extremes of the hydrologic cycle associated with climate change. A colleague of mine at the University of Wisconsin-Milwaukee, UWM, Sandra McClellan, goes out and dips for E. coli bacteria after it rains really hard. And you can see, at that South Shore beach, flaming blue high counts of E. coli bacteria after it rains. And so this is a recreational exposure risk after heavy rainstorms. The other problem in my state of Wisconsin is that of course, we're seeing more heat waves. We're also seeing more flooding. And if any of you have ever been in a flood and survived the flood, you know that cleaning up your basement is really depressing and a real problem. And so now, not only do climate disasters cause post-traumatic stress disorder, but major storms are leading to what psychiatrists and psychologists are calling pre-traumatic stress disorder from anxiety of having your basement flooded yet again. And there are other risks there as far as mold, fungus and mold growing, and risks of asthma. There's another dimension that I want to mention. Tony talked about this, about the ethical challenge, and the richest people in the world are causing the problem, and the poorest people are suffering. We did a study, it's more than 10 years ago, where we looked at comparing the countries that had the most climate-sensitive diseases that were already being affected by climate change, primarily malaria, malnutrition, and diarrheal disease. These are the countries suffering the most. But on top, those are countries, this is a data-driven cartogram. So this is real data, data-driven map. These are the countries producing the most, or producing CO2 emissions. And it's a 50-year aggregate. So from 1950 to 2000, the United States is the #1 country causing today's climate change. Now, even though that China now is out polluting us, today's climate change problem is the United States we're the #1 most guilty country for this, because greenhouse gases last in the atmosphere for 50 to 100 years. So we have been the guilty party. Now, of course, Europe's pretty bad, and so is China. But look at Africa. I mean, they're not causing the problem. And, on average, getting back to your slide earlier, Tony, on average, an American emits 6 times more CO2 than the average global citizen, or about 50 times more than someone in a poor country. So the title of this paper we published was Climate Change, Our Greatest Global Ethical Challenge. This paper got around, and I was fortunate enough to present this ethical paper to His Holiness the Dalai Lama in the year about 10 years ago, about 9 years ago. And he's looking at that map that you just saw, and he asked me, he says, "Jonathan, if you know pollution kills, your country's not showing much compassion, correct?" And I started answering the question, and then I told him I would get back to him on this, because this is the quintessential question. We know it's a problem, and we know that our pollution, and especially disrupting the world's climate, is killing people, and especially in other countries, it's not ethical, it's not fair. And this moral imperative, now, you see Greta Thunberg there when she started her, this is Swedish for School Strike for Climate, that it is an ethical challenge, that we are just polluting away and burning fossil fuels and cutting down rainforests and not really caring about the next generation. And of course, she has been, the youth movement and the Fridays for the Future movement has taken off, and this is something that is extremely important to talk about, the ethical issue here, as opposed to just talking about economics, health, and other issues. So I am really, it's fantastic to have this infusion of rationale to do something in a hurry. But I don't want to pin everything on the children and say the children will save us. That would not be fair. But this is a welcome, really important new groundswell of pressure to get something done. And especially in lieu of this report, this report that I mentioned, that the Intergovernmental Panel on Climate Change was asked to write this report after the Paris meeting, because the question was, what would it take to just limit our warming to 1.5 degrees centigrade? Now, there's nothing magic about that number. All of the impacts assessments from the United Nations IPCC have been looking at 2 degrees warming is where it gets dangerous. You get above 2 degrees and ecosystems fall apart. Things will get really nasty. So when Paris happened, which was an unprecedented event with 147 heads of state showing up in one place at one time, more than any other heads of state showing up ever. It was a really important meeting. They said, what would it take? What do we need to do to stay below 2 degrees? And let's try to stay below 1.5 degrees if we can. So this report was answering that question. Well, the answer is pretty alarming. And that to just limit to 1.5 degrees, we have to cut our fossil fuel emissions almost in half by 2030. That was 12 years when that came out. So cutting by 45% our emissions by the year 2030 and getting to zero by 2050, that's soon. And this is where the children's movement is looking at this and saying, we have to do something immediately. But from my point of view, I'm a health scientist. I think that combating climate change could be free. I'd even argue that it could be a net gain. And this gets to the theme of my presentation, which is not only if we solve climate change would we avoid all of those terrible deaths and climate-associated diseases, but I'll just point over here that actually save lives way more than we ever imagined when you think about a low-carbon economy. What will it mean for health? And I've been publishing about climate change challenges and opportunities for global health, that solving the global climate crisis could be the greatest health opportunity of our times. And just last Friday, we came out with a new paper in the Journal of the American Medical Association that a low-carbon future could improve global health and achieve economic benefits if you look at 3 main sectors. First, we look at the energy sector, recognizing that dirty fossil fuels and the pollution that comes from burning fossil fuels kills 7 million people every year. 7 million premature deaths every year from air pollution. Food systems. Tony talked a little bit about food systems, and that if we are over-consuming meat in rich countries, a red meat diet is very hard on the environment and hard on our hearts. And finally, transportation. That by over-reliance on the automobile, we are promoting a sedentary lifestyle, and according to the World Health Organization, more than 5 million premature deaths are caused from sedentary lifestyles. So across these 3 sectors, getting to low carbon could be enormously beneficial. Let's take a look at the cost of clean energy. This is a study from 7 years ago, looking at what would it cost to invest in clean energy so that you would avoid emitting 1 ton of CO2. So invest in clean energy, avoid emitting 1 ton of CO2. It might cost $30 in technology. Notice this is only half the slide, right? So what happens when we burn coal and oil? We emit CO2, which is the most abundant greenhouse gas. Not the strongest, but the most abundant greenhouse gas that is warming the planet. What else do we emit when we burn coal? We emit all the nasty pollution that you know about. The fine particles, PM 2.5, nitrogen dioxide, sulfur dioxide, lead, mercury, depending on, if it's from burning coal, or from burning leaded gasoline. So we know that it's not just CO2. When you burn coal and oil, you emit all these nasty pollutants. So let's take a look at the one pollutant that we know kills people, sort of on a broad scale, fine particles, PM 2.5. So for every ton of CO2 avoided by not burning coal and oil, how much effect is there by lowering pollution, the PM 2.5? And what does that equate to? Well, on average, you would avoid deaths and hospitalizations that equate to $200 in benefit, health benefit, for every ton of CO2 that you do not burn or do not emit. So for you students in the back, I'm going to ask you a really tough question, okay? I want you to take a deep breath, okay? Take a deep breath and stay seated, all right? Now, here's a question. Do you see these numbers, 30 and 200? Which number is bigger? And this is the question that policymakers need to pay attention to, because I asked this question in the Wisconsin State Legislature, and I was happy that some of them came up to me and said, you know what? We've only been thinking about the cost of cleaner energy, of investing in solar or wind, and we hadn't even thought about the other side of the equation, which is far bigger. And of course, if you're in a place like India or dirty, polluted areas, this benefit is much higher. So this is a really important slide when you think about, okay, we're going to invest in clean energy. Don't just think about energy. Think about the benefit by getting clean air from clean energy. And I would argue that that $30 is wrong when you look at the price of solar. Solar, Tony mentioned this a little bit, the price of renewables is dropping drastically. 99% drop in the price of solar since the 1970s. And solar and wind have dropped 80 and 30% respectively just in the last few years. And a colleague of mine, Greg Nemeth, just wrote a book on why solar got so cheap, because solar's been dropping, and now it's like super dropping in price. And guess what? For the first time ever, according to the International Renewable Energy Association, or Energy Agency, according to the International Renewable Energy Agency, that if you want to generate electric power next year and build a plant to generate electric power, and forget about energy subsidies, forget about the environment, forget about health, just what's the cheapest way to generate electricity? First time ever. Renewables and batteries beat out any source of fossil fuels. So we don't have to wait for a solution. We just need the political will, we need more incentives, and it's, we don't have to wait for the solution. Renewables are here, we don't need to wait anymore. And if you look at, investing in renewable energy, many states have these renewable energy portfolio standards. And if you look at, this is looking at if you have 13% renewable energy that you need, the black is an investment cost, and the red is a health benefit from clean air. The gray is climate benefit, reduce climate change. Now, if you were to double that to 26%, okay, more investment costs, but look at the health benefits. So again, clean energy offers enormous health benefits, and we have to think about health and energy. Energy policy is public health policy. And this paper that just came out last year, averaging, looking at health co-benefits of $94 per ton of CO2 reduced. So, golden opportunity. We hear this story, this argument, what about jobs? What about the fossil fuel jobs? Well, according to the U.S. Energy Employment Report from 2 years ago, 1 million US jobs are in renewable energy. That's 5 times more employment compared to jobs for energy coming from coal, oil, and gas combined. So the idea that, jobs, we got to worry about the jobs. There are more jobs in renewable energy. Now, from the health perspective, we absolutely need to take care of coal mining communities. They will become a vulnerable population in this transition. So we need to invest seriously in coal mining communities and those people, but we cannot burn any more coal. The other sector that's important is the food and agricultural sector. One of the last questions was about waste. Oh, we talked about waste. The world wastes 30% of food. The U.S. wastes 40% of its food. So there's already a problem. But if we are to have a more sustainable food system, that will be great for the planet and great for our health. This is from the People's Climate March a few years ago in New York. I am full of greenhouse gas. Do you have a stake in it? The idea that, red meat diet is not great for anybody. And it's the way we are raising cows in these concentrated animal feeding operations, very unsustainable compared to more organic grass-fed grazing. An organic dairy farmer told me it's the how, not the cow. But how we're growing meat is important, but also in a wealthy country, having too much red meat is not good for the environment. Look at the amount of greenhouse gases that come from agriculture. The world's top 5 meat and dairy companies create more emissions than Exxon, Mobil, Shell, and BP. So again, this is something we need to be thinking about as far as getting to a more sustainable food system. This is no surprise to anyone. If you look at different diets, this is looking at a high meat diet, low meat diet, fish, vegetarian, and vegan. The y-axis is looking at carbon dioxide equivalents as far as how much energy input and environmental disruption a high meat diet is compared to fish or vegetarian or vegan diet. You can see eating lower on the food chain is much better for the environment, but also it's better for our cardiovascular systems as well. Less saturated fat in the diet if you can get off of red meat. And look at the environmental conversion factors. This is looking at to raise red meat. Look at how much feed, how much water, and how much land use goes into growing protein from red meat versus from hogs or chickens. And as far as plant-based legumes, it's even lower. And if you want to think outside of the box and think about crickets and insects, which have a great amino acid profile, we need to change the way that we're eating. And getting to a more plant-based diet will be great for the environment and for our own health. And the last sector I want to talk about is the urban sector. This is a former postdoc of mine, Dr. Jason Vargo, who came up with this term that, we are Homo sapiens, right? Well, since 2006, more people live in cities than in the countrysides, and that's going to accelerate. 75% of the world will live in cities in the next few decades. So he coined this term that we are metro sapiens. And so the city is now becoming our prototypical habitat. So how we design our cities will have a really important impact on our health. So what's wrong with this picture? Are we designing cities like this fitness center has designed its entrance? I would argue that we are making cities that preclude walking and biking safely. And I know that places in California are really problematic as far as getting around, except in a private motorized vehicle. That is not promoting physical activity. And in the United States, transportation is actually contributing to sedentary lifestyles. More than half of Americans do not even meet the minimum recommended levels of physical activity. Our obesity rates are ridiculous. 40% in adults, 18% in children. 600 Americans die from heart attacks every year. And here's the thing. Almost half of our car trips are really short trips. 2 miles or 3 kilometers, easily bikeable. And this is where we are designing exercise out of our normal routine. If you compare diabetes rates and also obesity rates, but this graph is just diabetes rates, and you compare, active transportation, cities that have the most walking and biking, which is up here, the most walking and biking have the lowest levels of diabetes and obesity. So it's not rocket science. We know that cities designed for alternative transportation, you get less disease, less chronic disease. And finally, when you think about urban design, thinking about how we design cities and green space, we have another benefit. That there's a study that shows that there's a correlation between reduced depression, stress, and anxiety related to green space, how much green space is in the city. And it's significant, like equivalent to the stress and anxiety from moving or divorce. I mean, this is a significant change. And a recent study in the Proceedings of the National Academy of Sciences showed that in Denmark, the association between the risk of developing a psychiatric disorder any time in someone's lifetime compared to their childhood exposure to green space, no matter where they lived, if they lived in a major city or in the countryside, no matter where that child grew up, if they're around more green space, there's less risk of psychiatric disorder. So I want to wrap up and conclude and tell you that, there are benefits to a low carbon economy, especially looking across the energy, food, and transportation sectors. And climate change, it's real, it's serious, it's now. But I want to just pause and ask this question and say, there are a lot of people, especially in this country, that don't buy the climate change science. And from this perspective of the solution to climate change, which is a low carbon economy, I would say, regardless of one's views on climate change science, even if you're a climate change denier, we can all support clean air from low carbon energy. Healthier plant-based diets, safe routes to schools, physically fit children and adults from cities designed for people, not just for cars, and reduce stress, depression, and anxiety from green space. So in conclusion, climate change absolutely is a health issue. It's a health crisis. And the solution to climate change, climate action for a low-carbon society, offers enormous health opportunities. So first step for all of you is to talk about this, talk about climate change as a health issue, and that the solution is a health opportunity. So spread the word. I have a 19-minute version of this talk, so if you Google my name and TEDx, I have a TEDx on this, Google my name and TEDx, and spread that around to your network and your colleagues, and talk this up as a health issue, because it really is, but it's also a health opportunity. With that, I thank you very much.
All right, we have time for some questions. If you raise your hand, we'll get a microphone to you. It's hard to see with the lights down, but here we have one down in the front row here. Who's closest? All of the talks in this series, once the four programs are over, will be posted on our website. Okay.
Good evening. I'd like to ask you a question about human nature and why human beings in this country who are reasonably well educated cannot seem to change their behavior, particularly their driving, reliance on cars that are fueled by fossil fuel, fueled by oil. Even here in California, the home of Tesla, only 5% of the new cars sold in California this year will be electric vehicles or plug-in hybrid vehicles. In one of the most eco-sensitive places in the United States. Why do you think it's so hard to change human behavior about climate?
So that's a great question. Of course, the hardest thing to change is human behavior. This is where, it's such a penetrating question because it's going to demand multiple levers, multiple inputs. So number one, it's not just about the individual. It's about what is convenient and what is economic. And right now, when you talk to electricity CEOs, electricity CEOs, they will tell you, we see the writing on the wall that renewable energy is the cheapest way to go. So the CEOs of electric power companies are wanting to ditch coal and go to electricity, go to renewable energy. And then it's a matter of local and regional and federal incentives to make it the right choice. The right choice has to be the convenient choice. So until we have an infrastructure that supports electric vehicles, and I know that what is it called? The company that's putting out the chargers, ChargePoint, at the climate summit in San Francisco a couple years ago, they said they're going to put out 1 million more charge stations in the next couple of years. So it's a matter of changing the system so that the right choice becomes the convenient choice. So I think there is personal responsibility, but it's more a matter of demanding local officials and state officials to make the right choice. And so it's a matter of getting out there and voting and doing that, as opposed to just thinking about the personal level. I'm going to drive a car. Well, I don't have a choice to either drive a car or ride a bike unless I have bike lanes, right? So I think it's more at the population level and the legislative level to make things happen, as opposed to personal choices.
Nationally, about 1/3 of the total energy use comes from transportation. In California, it's 60% because we have so many people, so many cars. But I wanted to ask you, the arguments are clear to renewable energy for cost, for health benefits, all of those things. But we still have a problem of storage. And what do you have to say about storage? The technology is not moving as rapidly there.
Right. So I will defer to the energy experts because I'm not that expert, but I will tell you what I hear from the experts in energy and of course, I'll just defer to the International Renewable Energy Agency report that said the cleanest, the most economic way to produce electric power, regardless of health, environment, or anything, is now renewable energy and battery storage. All of these things are advancing. Battery storage is getting better. I defer to the experts in energy and battery technology, but all that is getting better such that this agency reported that batteries and renewables are a way to go.
And I think renewables or batteries are certainly lagging so far. Who has another question? Raise your hand and we'll get you a microphone. Okay. Oh, way over there.
I've noticed a paradox. I grew up in the 70s. I went to elementary school in the 70s, and I've taught for the last 25 years. When I was in elementary school, we had our lunch on a plastic tray, and we used the same tray throughout the school year, and there was much less trash. And over time, we've become much more conscious of, germs and things needing to be sterilized and packaged. And now when I see my teenagers going out to lunch, they've got a bag, and inside that bag is a container, and inside that container is another piece of paper, and then there's the food, and then there's the plastic utensils that are also wrapped, and it's basically just this trash bag afterwards. And it seems that that's how we live now, that we produce so much trash in the name of sanitary. So it's just this paradox. I'm not saying I don't really know what's right, but how do we keep clean and not spread germs and then not create mountains of trash?
Right. I mean, your question is one that points to the fact that there are a zillion different interventions that have to happen, be it from burning fossil fuels to what we do as far as wrapping and waste. An engineer once told me that, oil, well, I mean, there are now substitutes for plastic. You don't have to, it doesn't have to be petroleum based. So there are a lot of different interventions now looking at biodegradable wrapping and a lot of interventions like that. We have to be thinking outside of the box, no pun intended, the box. And we really need to be thinking on all these different levels, how many different ways we can conserve. We had a student do an analysis for Wisconsin asking the question, can we get all of our electricity from in-state sources rather than spending billions out of state for coal-fired electricity? And the answer was yes, we can, through wind, solar, keep nuclear exactly as it is, not more nor less, and conservation. And so conservation for energy, but conservation across all of these issues as far as food waste and other forms of that. You go to co-ops where you have bulk food, that's one way to go. So I think it's just being in tune with all of the ways that we are consuming natural resources, and we have to take a hold of each one of those.
I want to come back a second to that map that you had that showed the bloated United States with greenhouse gas emissions and the very skinny South America. That was per cap, as you pointed out, per capita. And we emit something like 6 times many other countries. But right now, if you look globally, about 2/3 of all greenhouse gas emissions come from Asia, where poor countries are lifting themselves out of poverty, using fossil fuels just like we did 200 years ago. And we fool ourselves that somehow, if we in the United States or California went to zero, it's going to make a difference. It's a good model, it's a good example, but comment on that.
So great observation. My comment is simply to look at what happened in Africa with cell phones. They leapfrog technology. I was in the middle of Ethiopia in a place with nobody around, this wild park, and I had 3 bars on my cell phone, whereas if I go out of Madison, Wisconsin, 20 miles, I have no cell phone service. So, they did not build landlines in Africa. They leapfrogged to the cell phone. And they have an opportunity to leapfrog to clean energy, especially with this ridiculously, this shocking news that renewable energy is the cheapest way to generate electricity. They have an opportunity to leapfrog and not follow our dirty energy path, to just go straight to clean energy. They don't have to repeat our errors. I think that's where there's a golden opportunity.
We probably have to help them.
when we do need to help them.
Who has another one? Raise your hand. Do we have one over here? Can we get a microphone?
So you were talking about how by 2050 we're going to be achieving, or the goal is to achieve a carbon neutral world. So specifically, how feasible is that to actually happen, considering that it's only 30 years from now until we actually are looking towards achieving such a, from our point of view at this point in time, a very almost unreachable goal?
So, you know, things change very slowly until you hit a tipping point, and then things can change very rapidly. We've seen this in a number of different cases where it seems like nothing's going to change, and then a tipping point happens. Personally, I think this new revelation that renewable energy is competitive. When I was in the negotiations in Spain, in Madrid, I was at the climate meetings there, and I raised my hand in a session with these electricity utility CEOs, and I said, don't forget to mention the health benefit from clean air. And their answer was, that's great, but we don't even need that argument anymore. We would be crazy not to invest in renewables because they're cheaper. So, and then there are more jobs. You know, right now it's the leaders of governments, and especially our own government, but other places around the world that are just, putting subsidies in fossil fuels, which is ridiculous. And I think what's going to happen is that industry is going to go forward and show that a low carbon path is economically competitive and the way to be a leader, and then the governments are going to follow that and say, gosh, that's great. We need the governments on board. That's a lot of money. That's a lot of incentives. But I don't think, I don't want to be overly optimistic. But what I want to say is that the markets are changing, and especially looking at the energy markets. And when you have a Republican mayor in Texas that is putting out local ordinances to say if you're going to build a new building, it has to have solar on it. And when you see solar panels on the roof of the coal mining museum in West Virginia, those are signals that things are changing. And I think that it's going to be, at the local level and in energy, when you just look at the economics, that things can move quickly. And with the youth movement putting a lot more pressure on leaders, I think that's also game-changing as well. So I don't want to be overly optimistic other than to say when things start changing, they can accelerate.
But I think your skepticism is well-founded when you think that in the last 2 years, the global emissions have gone up. And so, yes, when you get one of those inflection points, a tipping point, things can change dramatically, but not yet. Who has another one?
Mine is not really a question. I just wanted to say, well, I came onto this earth in 1950. I've been teaching for 47 years. And I was so excited to see all these young people here tonight because they're going to make a difference.
And we are too, and is Ben, where are you, Ben? So, Ben, we thank you for getting so many students to our programs here. Thank you.
I would also like to thank all of you for being here, even though I know some of me may have been somewhat forced. It's a class requirement or something. I don't know. Extra credit, maybe. But for whatever reason you're here, thank you.
I thought they all came as volunteers. I didn't realize you made it mandatory. No, I'm kidding.
I want to apologize for what my generation has left you. And also pass the baton to you, even though I'll do what I can for whatever remaining years that I have, along with many other adults, people down here. But thank you so much.
I'm a registered nurse, and I take care of patients who have fevers, of course. And it appears to me, and as the title of this presentation tonight is, The Earth Has a Fever. And as a nurse, I would be complicit if I didn't start cooling measures. And I'm wondering, has anybody started to talk about how to cool the earth? When we first moved to the desert when I was young, my mother taught us to always feel the rocks in the evening before we sat on them, because she was teaching us about radiant heat, and that the rocks would retain the sun and the heat, and then it, radiated out back at night. And with the movement from rural to urban areas, we have covered large parts of the earth with roads and sidewalks and buildings. And it seems to me that if we started to tear up streets again or things like that, that we could actually start to reduce the heat retention of the cities. Recently, one of the IPIC theaters showed Meet Me in St. Louis, which was, the Judy Garland film about 1903 in St. Louis. And the film was interesting because all the streets were dirt back in 1903. But we have since just created an environment that retains heat. So I was just curious if you've heard of it.
So I so much appreciate your question, and especially because you're a nurse. And I have a couple of things to say. First, at the global scale for cooling, they talk about geoengineering. Beyond my expertise, and it's scary. And you don't want to experiment when you just have one planet. But so there's geoengineering that I think could be quite dangerous, and I'm not going to talk more about that.
I'll say a word about that when you're finished.
Yeah. Now you're talking about the urban heat island effect, where black asphalt roads and concrete buildings absorb the heat. It can be much hotter in the urban core because of the urban heat island effect with all that black asphalt and concrete. That's a problem, and that's why greening a city is a great idea. And if we can get some of the concrete up and turn it into green space. But also, we did a study on air conditioning, and we found that if on average, I think we looked at the eastern United States, and on average, electricity for the eastern United States is 60% from coal-fired power plants. And we did a modeling study that found that in the year 2056, 36 years from now, that the intensity and frequency of heat waves will require more cooling demand for buildings. And how do you cool buildings? With air conditioning. And if you are getting your electricity from 60% coal-fired power plants, you will kill 1,000 people every year from the air pollution from the increased electricity demand if we are burning 60% coal for electricity. Now, the point of our study was not to say air conditioning is bad. Air conditioning saves lives. It's great. But it has to come from clean electric power. And you will be trading problems if we over-rely on air conditioning that comes from dirty power plants. So that's about that issue. Finally, being a nurse, you are the most trusted messenger in the country. Surveys of who trusts people, professions, 93% of Americans trust nurses, 91% trust doctors, mid-80s trust scientists, and then drops down, politicians are on the bottom, right? But nurses are the most trusted messengers. My message is that climate change is a health emergency, and we need simple messages repeated often by trusted messengers. So nurses should be out there, and they are already out there pushing this. So thanks for being here.
Yeah. And there is a lot that can be done and is being done to reduce the heat island effect of cities. You can paint, or we have white roofs. It makes a big difference. Plant trees instead of cutting them down like many cities are doing. And you can put reflective material into concrete and asphalt that increases the reflectivity. But I want to just say a word about geoengineering, because as you know, in the last IPCC report, they said that it's unlikely that we could keep the temperature below 2 degrees without looking seriously at geoengineering. There are two different models. There's what's called SRM, solar radiation management. That's where you put particles into the upper atmosphere to reflect away some of the sunlight. We know that it would cool the Earth because every time we've had a major volcanic eruption, it has cooled the Earth for a short period of time. Those are dangerous. We don't know the consequences. The other part of it, though, is called CDR, carbon dioxide removal, where you actually suck carbon out of the atmosphere and lock it away. Trees do it, marshes do it, mangroves do it, wetlands do it, and there's exciting research that's being done in the laboratory using physical and chemical methods. The trouble is, right now, they're not scalable to make a difference. But I think it's probably in our future.
Yeah. Well, let me make one simple analogy. We need all of the solutions we can come up with, but if we emit the carbon and it's out there and we deal with it, wouldn't it be better to just not emit the carbon and go with it? And like you can mop up the floor, but if you're not also turning the faucet off, you don't want to keep mopping up the floor.
No, and that's absolutely right. But
Yeah.
as you said, we have a large enough inventory of CO2 already in the atmosphere that the Earth will warm, sea level will rise, all extreme weather events will increase well beyond the end of this century. So it's even if we went to zero,
Right.
we've got to figure out how to deal with that. We'll take one more, and then we're going to say goodnight. Who has a good question for us for a closure? It's hard for me to see who's got a hand up. Anybody? Well, we thank you all for being here.
There's one up there.
We have one? Okay.
Yeah.
I can't see. Where?
Okay, so you discussed a plethora of benefits associated with slowing the effects of global climate change, and yet governments like the United States and in other more developed countries have yet to do anything about it. What do you think is hindering them from taking action when it is so needed, considering these ostensible positive effects?
Right. What is keeping governments from acting? I think it's money in politics. And I think that really, at this time, we need to pivot to local leadership and go with the local and more regional efforts, and also industry is recognizing that they don't want to fall behind. They see even oil companies are putting in carbon pricing into their planning even before there's a price on carbon. So I think, we need to, I wouldn't say ignore the federal government, because we need to keep hassling them and writing your senators and representatives. But I think it's time where we realize there are innovations all over the place, and that right now we pivot to the local leadership while we wait for some of the people in the federal government to hopefully change in the next election, which means the most important thing you can do is get out and vote, and get everyone you know to get out and vote. Oh, and by the way, the United States cannot officially pull out of the Paris Agreement until the day after the election in November. So the election in November is an election about climate change.
Yeah. I have to ask you, there was a report recently that said that the most ideal city in the United States to move to by 2050 will be Minneapolis, St. Paul, Minnesota. Now, a guy from Wisconsin, that's probably hard to accept.
Yeah, that's tough. That's tough.
All right, please join me in thanking our two speakers. I thought this was really well done.